Welcome to the Edinboro Lake Watershed Association's online video series. In this video, we will look at the origin of the thermocline in Edinboro Lake and discuss eutrophication, which is considered to be one of the more significant environmental issues facing Edinboro Lake. Each spring, it eventually stops snowing here in Edinboro, and the sun comes out. Heat from the sun warms the surface of the lake. Because warm water is less dense than cold water, a layer of less dense water forms along the surface of the lake. Cold water, being more dense, becomes trapped near the bottom of the lake. The boundary between this warm surface layer of water and cold deep water is known as the thermocline. In Edinboro Lake, the thermocline forms each year sometime around the first week in May and persists until sometime around the first week in October. The depth of the thermocline is about 10 feet, and there's very little mixing between the warm surface water and the colder water deeper in the lake. At the surface, typical temperatures in July and August are around 75 degrees, and the water at the bottom of the lake stays nearly a constant 50 degrees Fahrenheit throughout the entire summer. After the thermocline forms, plant nutrients, nitrogen and phosphorus, enter the lake from runoff from the surrounding watershed. These plant nutrients cause algae to grow near the surface of the lake where sunlight is able to penetrate the water. Eventually, these algae die and sink to the bottom of the lake, and the sediments at the bottom of the lake contain a large amount of decaying algae. As the algae decay, they consume oxygen from the water at the bottom of the lake. And eventually you end up with an oxygen-poor layer near the bottom of the lake and an oxygen-rich layer of water near the surface of the lake. The oxygen is drawn out of the water by the decaying algae until there's essentially no oxygen in the water below the thermocline. The surface layer stays oxygen-rich because it's in contact with the atmosphere. Throughout the summer, this oxygen-poor layer becomes essentially a dead zone at the bottom of the lake. Fish and other organisms that need oxygen to survive can only live within the upper part of the lake. Eventually in the fall, the weather starts to get colder and the thermocline breaks down. Cold water from the surface of the lake sinks to the bottom, and the water mixes in the entire lake, and the whole lake becomes oxygen rich again. You can always tell when the thermocline is about to break down each fall because you'll have a couple of mornings where there's a dense layer of fog forming over the lake. Eventually there'll be a real cold morning with no fog, and you'll know that that's the day that the lake turned over and the thermocline broke down. This condition where you have an oxygen-poor dead zone near the bottom of the lake is known as eutrophication. Eutrophication is caused by an excess amount of plant nutrients such as nitrogen and phosphorus entering the lake. Eutrophication literally means overfed. This is an aerial photograph of an experimental lake in Canada where they were able to divide the lake into two halves. One half they added phosphate, the other they did not. And you can see the effect that the phosphate has with the really heavy bloom of algae in the bottom part of this photograph. So to summarize, eutrophication of Edinboro Lake is caused by excessive amounts of the plant nutrients phosphorus and nitrogen entering the lake in runoff from the surrounding watershed. If we want to reduce the amount of eutrophication in Edinboro Lake, we can accomplish this by limiting the amount of phosphorus that enters the lake from the surrounding watershed. Phosphorus is the nutrient that we target because it's the limiting nutrient for plant growth in the lake. The plants and algae will continue to grow as long as there's phosphorus available. Once all the phosphorus is used up, the plants will stop growing. This diagram shows the various sources of phosphorus in any watershed. Point sources are places where you have a pipe coming into the lake with water containing pollutants such as phosphorus. Point sources for phosphorus would primarily be wastewater treatment plants. There are no point sources currently discharging into Edinboro Lake. About a third of the phosphorus entering Edinboro Lake comes from runoff from natural areas such as forests. These are non-point sources that come from runoff from the surrounding watershed. Another third of the phosphorus entering Edinboro Lake is non-point source runoff from agricultural areas. This includes fields such as hay fields and row crops, and also phosphorus that's derived from manure from livestock. About 1/3 of the phosphorus entering Edinboro Lake comes from runoff in developed areas. This includes parking lots, roads, and buildings. Elimination of runoff from these areas involves stormwater best management practices, which are the subject of other videos in this series. If you have any questions about the content of this video or want to learn more about the Edinboro Lake Watershed Association, contact us at the email address shown on the screen.